All right, welcome to the Mercury Research Hour with Canaveral Research Center. I'm Courtney, and we've got a nice little group in here. And, you know, we want to talk about what you want to talk about this hour. On the one hand, we've covered a lot of interesting stuff in the last month. We've looked at a lot of the details of research software, particularly like the Sirius and Kepler programs. And we've looked at some, some questions in research like the chi-square, whatnot. But as I said, this morning is more about what people want to talk about and what questions that they have. So I just want to kind of take a group consensus starting off and see if Faith or John or Mo or Mitch, if you've got anything on your mind that you think we need to be elaborating upon today. And I've got most of your mics on. Okay.
Yeah, can you hear me?
Yes.
Yeah, the thing don't know anything about and would be interested to hear about are some of these statistical tests that get referred to around astrology, chi-square and p-values and things like that, because I don't know the things that I'm interested in, how to collect the data that would satisfy inputting that sort of statistical technique into what I'm doing.
That's so relevant, John. Thank you for getting right to the point.
Yeah.
You know, and I'm putting my phone on Do Not Disturb here because
I would like to see some research on transits. Everybody is more fixed on the birth chart and, you know, what does that mean? What do those people like? What do they do for a living? I think that astrology, I mean, with a transit can be so revealing, especially if you get like a really specific transit. And then you monitor the people's lives, you know, during that transit, I think is interesting to see how it correlates in everybody's life that's going through a similar transit.
Well, I agree, and I think transit research is incredibly important. At the same time, it's a little more complex than just, you know, researching natal characteristics, because when you talk transit, now you're talking about two charts, natal chart and the transit chart. And that's that one feature that Sirius has that doesn't really exist in some of the other, not any of the other programs. However, you know, and that's something that I put a lot of thought into for a lot of years, and there are a couple of projects out there. I know there's a guy that did a thing on composers and when they compose, musical composers, and something along the lines of when they compose their masterpiece or, you know, achieved fame. And we could dig that one up. There's, you know, Nick Collerstrom's Eureka effect is kind of along those lines, where he looked at, I think he had 17 famous scientists, and he had the exact moment when they had their Eureka moment, you know, where they made their big discovery, and he went into like harmonics with that, you know. But I agree, Mo. I think it's really important. I'd like to see more research on it, bearing in mind that, you know, there's certain complications that come up right away. Okay. How about you, Faith? What's on your mind?
Well, I am happy that you can hear me. Can you hear me? Oh, shoot. Oh, good. I'm happy that John brought up the question of definition. I'd love to hear that. I love Maureen's question because, to me, well, from the standpoint of my particular corner of the world of researching particular aspects, progressions and transits are where the rubber hits the road. So, yeah, I love what everybody's brought up today.
Right. And there is a feature in Sirius that will allow you to do a comparative between chart. analysis. So at least, we have a starting point there. Okay, well, good. I want to go back to the question that John raised about basic statistical tests. And I want to frame what I'm going to say right away by saying, like, here in the classroom, you've got two completely different kinds of teachers. Okay, on the one hand, you have Mitch, who is a professional researcher. He is a statistician, an applied statistician. And sitting next to him, you've got somebody like me, who is just a singer in a rock and roll band. I come from a more liberal arts background, and math and statistics aren't my strength, but at the same time, I think like philosophy and religion kind of are. And that's been my way in. So when we teach it, Mitch can really get into the nuts and bolts and, show you exactly how it's done and applied, etc. Whereas I tend to talk more about, the story of it and what it is and what it means and, what the results mean. So I actually think that's an advantage. Like I said, you've got two very different viewpoints in here. And, John was asking about the p-values and the chi-square. And, those are probably the two that come up the most frequently, or at least come up first in a lot of the research that we've looked at. I mean, the third one would be the correlations, the Pearson correlation, that kind of thing. But, p-values are very relevant to astrology. And most of the papers that we look at, and even that we've been publishing, right away we go to p-values, and right away researchers will ask for them. And the p stands for probability. It's a probability value. And I think it's helpful to think of it that way, especially if you're not Mitch, if you're not a mathematician like me. And it's essentially a way of calculating how likely it is that the result that you got is just due to chance or not, or maybe it's actually statistically significant. That's what the p-value tells you right off the bat. And so in astrological research, you can see why it's a handy tool that people like to pull out right away. You're looking at a sample of 300 doctors and you find out that, 250 of them have, Mars and Scorpio. This is just theoretical. If only it were that easy. Then you can do a calculation right away to show what's the probability of Mars being in any of these signs, and how unlikely is it to get this kind of a result. All right, so that's the story of it. That's the philosophy of it. Mitch, would you get into the nuts and bolts a little bit more?
It's the likelihood that, for most tests, it's the likelihood that the result is not zero, that it's something other than zero. And traditionally in research, the norm is we like a 95% confidence. So the p-value for that will be 0.05. The probability.
Yeah, that's an important thing. You're looking for a very low p-value, and it's going to be, and the cutoff point I think has moved in some situations, but it's, I think off the top of my head, it's like 0.03. Am I close, Mitch?
0.05 would be the customary. If you want to be really confident, you go to 0.01. And if you want to be really, really confident, you go out 0.001, 1/10 of 1%. So it just depends upon how confident you want to be in your results. I'm trying to be as non-technical as I can be in the discussion of this.
Yeah, and I think on some level it makes it easier to lose them like that. Okay, let me ask you. when we talk about a 95% confidence level, you know, that's a very important part of understanding the p-value. What do they mean by a 95% confidence level? What is that?
It means that for a hypothesis test, it means that you're 95% confident that the result is not zero, is non-zero.
Okay, stop. Now stop right there. Like, the result is zero. What does that mean? The result of?
Usually, the null hypothesis will be that the result is non-zero, that it's something other than zero, and the alternative will be that it's zero, that there's no effect whatsoever.
Okay,
so,
are you guys following that?
Yes.
Okay.
So you're testing whether or not there's an effect versus there's not an effect. If there's an effect, the result will be non-zero. If there's no effect, the result will be zero for the test. That's usually the test that people are using. If they don't specify anything different, that's the test that they're running by default.
So what areas would be relevant? Are you looking at quantities? 95% of doctors with Mars in Scorpio, for example. Is it a quantity based, or I'm not quite sure in what areas it would apply or not apply?
It is the confidence interval is the I'll do this in a non-technical, without going into a lot of math, and needing a whiteboard or a blackboard.
Tell them the story.
Thank you, Courtney.
Anytime.
Well, can you give examples where astrologically it may apply and astrologically where it may not apply?
Well, astrologically where it applies is, for example, the research that I'm doing on prisoners and the survey data. And so what I want to know is whether or not the variable that I'm looking at, it could be that they have Mars in Capricorn. I'm just taking this as an example, right off the top of my head, that they have Mars in Capricorn. So I would look at the data to see whether or not the data shows that Mars in Capricorn is non-zero for having an effect on whether or not somebody was a murderer, for example. So, and I want to be 95% confident, so that creates a confidence interval, which is derived from the standard deviations of the data. When you have a confidence interval like that, the data is generally assumed to be interval level data. Now you can put confidence intervals, you can get confidence intervals for nominal level data, which is what a chi-square test is used for. Chi-square statistic is used for, is for nominal data. Nominal data is where it's not like 1, 2, 3, 4, where 1, 2, 3, and 4 have mathematical meaning. One is smaller than 2, 2 is smaller than 3, 3 is smaller than 4. Nominal data is things like race, gender. So it's female, yes, no. It's race, African American, yes, no. Or even race, African American, white, Hispanic, etc. Those would be nominal variables. Nominal variables, when we assign a number to them, it's just an arbitrary label. It's not, doesn't have mathematical meaning. It's just a label that we've assigned. Am I helping at all? John?
John?
Yes. Yeah, I'm trying to get my boundaries as to what it is that I should be asking myself.
Well,
doing as to
I think with any research,
and it's easy enough just to look at a chart and look at an event or look at a birth chart and just say that's the answer and that makes sense, and then you then start to build it up. But it's the questions I need in my mind that gives me the parameters to say I'm on the right track.
There you really do need a p-value. You need to, if you're talking about statistics, you need to be able to demonstrate that the effect is significantly different from 0, meaning a statistical significance. And that's what the p-value is giving you. Is it far enough away from 0 that you can be confident that it's not 0?
Okay.
I'm looking for an example right now, and I'm trying to pull it up because in my
try John Ruiz in your correlations.
In my study on the head coaches, where we're just comparing a complete data set of all the NFL head coaches that have coached in the Super Bowl era.
Then you don't need a p-value if you got the whole.
No, wait a minute, we did, because we split them into the ones that won championships versus the ones who didn't. We were looking to see.
Still got populations.
Difference. So as soon as we had split them out right away, everybody asked, well, what are the p-values? Because we found, what looked like very significant differences, but we had to measure and see if they were actually significant or if they would be maybe just due to chance. And that's what the p-value does.
But Courtney, you only need a p-value when you have a sample, not when you have a population. When you have a population, the p-value doesn't give you any more information.
Actually, Courtney and Vincent both reviewed the paper and insisted on p-values.
Yeah, well, they're mistaken.
Everybody that reads it, that's the first thing they ask. What are the p-values?
Well, from a statistical standpoint, from a statistician's standpoint, a significance test only applies to a sample. When you have a population, if you want to know if the value is not 0, you just look at the value and see whether or not it's 0 or not. When you have a sample, there's a sampling distribution, okay? And when you have a sample, the idea of a significance test is my sample large enough that I can be confident that in the results that I'm seeing. So significance tests only apply to samples. They have no meaning when you have a population, and all they can do is confuse you when you have a population. All you can do is come to a wrong conclusion when you use a significance test with a population. I'm sorry, I would respectfully disagree with Courtney and who else? Robert Curry.
I think I don't want to get sidetracked on this issue because I think if you actually saw it in the context of the paper, it's actually perfectly legitimate. And in fact, you did review the paper and didn't say anything about not using it. So
I don't remember reviewing it, but if it's actually population data.
What it does, to my mind, and again, this is my more, liberal way of interpreting it, is, we see differences between the champions and the non-champions. What the p-values do is show whether they're big enough to be significant.
Right, but the significance you're talking about is statistical significance, Courtney. And statistical significance is sample-based. It's based on a sampling distribution. When you have a population, there is no sampling distribution. You have the population. The idea of a significance test is the difference between is looking at a sample and saying, is that sample big enough that I can conclude that the statistic that I have, a statistic is a sample measure.
Okay, I'm going to pull up the paper now. I was looking for it before, but I mean, now that we're going into this, I think it'll make a good example.
And I think it's helpful for others here to hear this conversation about what a statistic is. A statistic is a measure from a sample. A population, we have a parameter. Okay, so statistics are sample-based. Parameters are population-based. When what you want to know is whether or not the sample is reflective of the population parameter, you use a significance test. I've been fighting this battle for 20 years with non-statisticians. Statisticians all agree, significance test, population, big no-no, don't do it.
I have a question on that, using the managers of the North American football teams. Would the sample be all the managers of the football teams?
She had
Or
the
is it a
population.
sample elsewhere, like chefs or, I don't know, sub-aqua divers? Or what's the sample in that context?
She didn't have a sample. She had the whole population. She had everybody.
Well, what would your suggestion be then of a sample in that scenario?
If you drew a random sample of coaches, of NFL football coaches, then you would use a significance test.
Okay, so if you had all the coaches,
That's the population, right?
that's the population. Okay, so everybody's the population.
Everybody's the population. So in your case, if you had all the horse races,
Hmm.
you would have the population. You wouldn't need a significance test. You wouldn't need a
Okay.
p-value.
I found it and it's opening, but I've got the.
But you don't. But you, Robert,
So what's the
don't have.
difference
Mr. John,
What's the difference? Sorry, go on, Mitch.
John, you don't have you don't have all of the horse races. You have a sample of horse races.
Correct. But in the footballers or the coaches example,
Mm-hmm.
if there are 500 non-winning coaches and there's 50 winning coaches,
Mm-hmm.
why would you take a sample of the 500 rather than using all the 500?
That's correct. If you have the whole population, you don't need a sample. You would be throwing away information by using a sample.
Okay.
You get the whole population. You want the whole population.
Okay, I've got
Okay,
it.
good.
I've got it, and I've got it queued up. Yeah, and then in this one, we used a complete data set of all the head coaches that had coached in the Super Bowl era, and we separated the ones who had won championships
Right.
and the ones who had not won
Right.
championships. So I'm going to go to the screen share and show you that Word file, that paper, and we're looking at the results here. I hope you can see that. So here's, if you can see that black and white
Mhm.
graph, the one on the top is the champions, and this is complete through December of 2017. There were
Right.
54 that had actually won championships, and we're looking at the positions of the Sun, Mars, and Jupiter. And as you can see, there's a big spike.
Right.
Capricorn, and then Gemini is very low. Aquarius is very low. Then you have the non-champions, and it is a complete set.
Mhm.
So it's much bigger. It's 168. Of course, again, looking at the Sun, Jupiter, and Mars. And you get, this screen's a little large, so I don't know if you can entirely see this, but you get some very complementary differences. Capricorn is the lowest for the non-champions, but they're very high in the air signs, Gemini and Aquarius. So then when you go to the totals, when we look at the totals for the elements, it further clarifies the information in figures 1 or 2. The championship coaches score high in the earth signs like Capricorn and Virgo, low in the air signs like Gemini, Libra, and Aquarius. Conversely, the non-champion coaches score high in the air signs and low in the earth signs. And the differences were not only very markedly different, but they were very complementary by sign and by element. And then I get to the p-values, and again, Kiosty first did the p-values, but Vincent, again, as soon as Vincent saw that, he was like, what are the p-values? And he calculated them as well. So yeah, Kiosty said according to this, he's using the chi-square test of independence with the p-values. The sun distributions in figures 1 and 2, the Sun, Mars, and Jupiter are different in a statistically significant way. And that's a very low p-value, 0.007.
Right.
You know, much less than 1. Hence, you have a fortunate, clear confirmation for your expectations. So, what's your take on that, Mitch?
My take is that he's misapplied the significance test. I run into this with non-statisticians all the time. People who went to graduate school where they're used to working with samples, and with a sample, that's a legitimate question to ask. But with a population, it's not a. The significance test is meaningless.
Okay, so you're saying that the p-value should not be used because it's a complete population.
Right, and it can only mislead you. What if your p-value had been 0.1? Then you would have said, well, it's not statistically significant, therefore there's no effect. That could have happened. Had that happened, you still would have been wrong. You would have been wrong in that case because there is a significant difference between those two graphs. You can see it visually. It stands right out. And if you graph the numbers, you could see you could see it on a table.
Yeah, I've got it in a table too. It's pretty striking, and
right.
And again, it's not just differences; they're very complementary.
Right.
And here they are, like in a table where I've got red for the high score and green for the low score. So like the champions are high in Capricorn, and
high in Earth.
High in Earth, and the non-champions are low in Capricorn. The champions are low in Gemini. The non-champions are high in Gemini. Right. You know, so it's very, very complementary. All right, so what would you use if you're not going to go for a p-value in a circumstance like this? What would you use?
You make an argument that I would make the argument here based on the population data, and I would draw the same conclusion that you came to using p-values. I just wouldn't use the p-values to get myself there.
And he's using a chi-square test and p-values.
Yeah, chi-square test is again he can use the chi-square. Well, the chi-square is a test of significance, statistical significance, so it doesn't really make any sense. You just look at the table and see whether or not there is a substantive significant difference. That's a difference. There's statistical significance and there's substantive significance. Substantive significance are the difference between head coaches who won Super Bowls different from head coaches that didn't win Super Bowls. And in your case, I would make a substantive argument that they're different enough, yes, and in fact, as you say, they're complementary, and I would point that out.
Well, yeah, and I did. You did read this paper over. I did give it to you to review, and all you said was, "My goodness, you seem to have like checked everything. You know, you checked all the details." That was all you had to say. So I wish you would have brought it up at the time. It's going into publication right now. And again, Kiyosti and Vincent have all signed off on it. So.
You're not the first person. You're not the first person to make that mistake. That's for sure.
I didn't do the p-values. And again, like everybody that chimes in on this paper right away, they run the p-values.
I understand.
So I think you know, maybe
it's very common for non-statisticians to do that. It's almost a reflex.
I don't think it's fair to call Kiyosti a non-statistician, or Vincent for that matter. You know,
I don't know what their background is with statistics. I don't know. It's
pretty impressive. So I think what you're pointing out is that most people work from samples, and this is a data set. A complete data set, and that's a different. And whereas going back to John's project, John's trying to work, and correct me if I'm wrong here, John. John's trying to work with
samples.
No, I think he wants to work with a complete data set to get like an entire racing season collected. Is that correct, John?
Yes, at the moment I'm just focusing on who wins or who almost wins, who places in a race.
But is it a population? Is it every race, or is it
Yes,
selected races?
that's the advantage of what's happening now. There was a racing season starting last week that will go through until next April, and it's possible to do all the races.
Okay.
So I can get a complete data set. What I've hesitated on doing is, at the moment, it's time enough recording who wins or who comes second.
Mm-hmm.
Do I need to record the amount of people or all the individuals concerned that lose at the same time?
Not following.
Well, if there's 10 people in a race, there's one winner, one comes second, and there's 8 losers.
Right.
It's hard enough doing the one winner and the person that comes placed to work out if that pattern then repeats itself at another similar time during the next 6 months. But for your statistical purposes, does it need to be a recording of everybody, of the other 8 people in some way that makes it significant?
Well, but John, right off the bat, I have a research design question. There may be, of the other 8 people in the race, they may be winning other races later in the season, in which case you're going to need a complete record for them.
And not only that, again, it goes back to the transit. Maybe the person who won was having a particularly good transit at that particular time, and maybe not so much the rest of the year or something.
Well, he's using a particular system with the rising sign. But again, you know, those other horses, and you're using the trainer and the jockey, I believe? Correct.
No, I accept Maureen's point, because I don't regard the information as being static. So it changes from birthday to birthday. So the data is moving forward year by year, subject to people's birthdays. So that's a refinement that's going on.
So I would think you'd at least want to have, even if you don't calculate the charts for everybody in the race, I think you're still going to at least need to have the record of because you might need to refer back to that if they win later in the season.
Yes, how many times they lose. Yes, no, yes, you've reinforced what I thought, actually. Yes, thank you.
Yeah, if you can get the whole population, you're always better with the whole population, John, than you are with a sample.
Quite.
Always.
Well, that brings us back to his question, and I think it's a pretty fundamental one. Let's say it's the end of the season, and he's got all of his data in place, and he's got his results. What is the best test to use to determine if his results have statistical significance or not?
Well, the test in that case is, as I say, it's eyeball. Is the difference between the I don't know what his hypothesis is specifically, but if he wants to know is there a difference between particular jockeys or particular managers or whatever, he looks and sees whether or not there is a difference between them, whether or not there's a remarkable difference between them, if he has the population.
And I mean, just taking it from a skeptic's
worthy of note.
Point of view, like, what is going to be sufficient to convince them that it's a remarkable difference?
When it's population, the first thing I would do is make the argument that a statistical test of significance is inappropriate in this case because it's population data. I would make that a paragraph. Okay, there are sources that you can cite in the statistical literature that make that point very forcefully.
Well, you could cite. For John and me, it might be a little harder, but maybe we could come up with some sources there. But okay, now I have another research design question.
The American Statistical Association and the American Psychological Association wrestled with this issue a long time ago and came to the conclusion that when you have a population, you don't do a significance test.
Now, here's the question. He's working with one season. He's got the entire population for one season. Could remember, the skeptics are coming in, guns a-blazing. Could they make the case that one season does not constitute a population? You need maybe 10 seasons or 20 seasons.
But if that's the case, he's got a non-random sample. And non-random samples, again, you don't use a significance test for. If you want to make the argument that one season is a single sample from n seasons, okay, then it's in fact a non-random sample. And with non-random samples, significance tests also don't apply, because significance tests are based on the assumption of randomness in the sampling method.
Right. Well, and that's the bottom line. Yeah, he's got a non-random sample.
Then a significance test doesn't apply there either. It's misleading.
And everybody is going to be waiting. If let's say he gets results and they are remarkable, even when you just eyeball them, then everybody's going to be waiting with bated breath for him to do the next season and see if he gets similar results.
Mm-hmm. I agree. People will
submit the case, and it does raise questions. Is it going to be the same from season to season? I agree. In tracking a lot of stuff in NFL and NBA, not always the same from season to season. There are variables.
Yes, I agree. That's where Maureen's suggestion for transits and other techniques becomes relevant.
Well, there's your transit test, Maureen, right there. There it is. Now, I mean, just to clarify, for my own benefit and for the other people listening for their benefit, John, what you're doing, and correct me because I'll probably be wrong, is you're taking the ascendant degree for the start of the race.
Correct.
And you're comparing it with both the trainers and the jockeys.
Yes.
See if they have some consistency in winning when that degree is rising.
I mean, effectively, it's a blind test on a natal chart or a transit chart. There must be some astrological reason why that particular degree is strong, but I'm not concerned as yet with understanding or finding out these individual charts. I'm more concerned about finding out whether a particular astrological point in time is significant for the individuals concerned. So they win at a certain time. You know, you might say Jupiter trines a natal planet and you expect an event. Well, if somebody's having micro transits on a daily basis, is it significant then? Are they meant to win at that time or not? And the slight advantage of this is that it occurs several times a day, every 365 days of the year. Now, so far, I'm on my third year on this, but I've just been literally following the winners. And there's enough to go on, like I said in the last talk. The money keeps going up. That's why I'm interested in asking the question. And I just don't know I don't know how to present it. And I don't know if I'm asking myself the right questions in collecting the data to take it a step further forward, other than just being, this is just of interest and it seems to work. You know, my next tests occur in 50 minutes time when the races start. They're all lined up and ready to go. I'll know my answers to my research in between an hour and 3 hours time. I don't have to look back 50 years for a transit or concern myself about what's going to happen in the next 2 to 3 years. It occurs literally day after day.
And you know, there are no easy answers. And I think that's why it's important to have these conversations and try to come up with the best design and the best methods. You know, there's a lot of ways to skin a cat, but we want the most effective and efficient way. There's no point wasting time or effort either.
Yeah.
And I do recall when we talked about this last month that I think, raised a question similar to what what Maureen is saying. You know, for example, let's say you have a jockey or a trainer who has a couple of wins when a particular degree is rising. And then he shows up to race on a day when his race goes off with that degree rising. But let's just say, for example, the moon is conjunct Mars, making a nasty square to that particular rising degree. You know, we might not expect him to be so fortunate and to be more frustrated under that kind of a condition.
That's why I'm interested in the significance of it, because if he races, say, 10 times and wins 7, is it significant? Is it not significant? That's the question I don't know the answer to, how I should go about answering that question or presenting any information about it. I accept there may well be a reason. I accept that there may not be a bad transit going on at that time, but somebody else is having a better transit at that time. But what's the probability of, okay, there's transits going on all the time, but you'd expect if somebody's strong for a particular year, that depends what technique you want to use. Like, you know, using perfections, for example, they're in a Jupiter year and there's a Jupiter rising sign occurring and he wins at that time. The next year on the perfection, he won't be in a Jupiter year, so he won't be as significant. But the patterns then start to repeat for somebody else. And I'm deliberately not trying to connect those together at the same time. I'm just trying to get the information that there is a significance of people winning at certain times, yes or no. The reasons why I just want to back away from, because like most things astrological, you can, like transits, you know, what aspects do you use, what orbs do you use, what other planets do you include in asteroids? It just becomes too many variables, and I'm just trying to strip it back to, do they win, don't they win, is there a pattern, full stop. The reasons why, well, if I get 4 or 5 years worth of data and there's a pattern there, then I can start asking that question. But at the moment, I mean, being flippant,
I'm going to put your camera on.
yeah, it pays its way.
Well, John.
Yeah, go ahead, Mitch.
John, I think what you want to look at is you want to calculate what is the average number of wins for jockeys and or trainers for a given astrological criteria. Just off the top of my head, the sign of the ascendant. So you got the sign of the ascendant, and then you've got you somehow get a count of an average count of the number of wins for jockeys, and then you look and see for each given jockey whether or not they're
yes, I've got that data already.
Okay, so you get the average, and then you look for a particular jockey to see whether or not they're different from the average, whether they're above average, and what criteria distinguishes those who are above average and those who are below average.
Yeah. So it becomes a sample not of all the jockeys, but a sample of the winning jockeys.
Yeah, well, it's not a sample. You're getting everybody, so it's a population.
Okay, so there is 2 populations, a population of all the jockeys, winners or losers, and a population of just winning jockeys.
Just winning jockeys is itself is a population. You got the population of all the winners. And you have the population of all the losers. You know, who won, who placed.
Okay.
But you're right, that's 2 different complete populations. And, you know, right. Going back to the head coaches, it might be interesting to compare the 2.
Right. Winners and losers we would refer to as subpopulations. They're entire populations, and they're underneath an entire population. So, and we treat them again. They're not a random sample. They're everybody.
Yeah. So you're saying that's better than a sample?
That's much better than a sample, because a sample, we're making an inference. We're saying, okay, we have a sample of a certain size. We don't know what the parameter is. We don't know what the population value is. So is this value different enough from 0 to assume that in the population, to safely assume that in the population, the value is different from 0? When you have the population, you're not making an inference. You just look.
Okay. So on the example of the head coaches, the fact that all the population of head coaches is there,
Right.
It's superior than using
A sample.
statistical p-value test, because
Right.
the argument is that much stronger.
Right.
Yeah, okay.
The argument is, when you have the population, all you have to do is look and see whether or not it's different from 0.
Mm-hmm. So again, going back to Maureen's examples of transits, if she had a defined population of people, head teachers in secondary schools in a particular town or something,
Mm-hmm.
and she wanted to, it's defining, it's the parameters of what you want to look at, isn't it?
Mm-hmm.
Be it by
Yeah, and
rising
I've
sign
been
or by transits that defines the quality of the information that you then derive.
I've been biting my tongue on making this point, but I'm going to make it now. You can't test everything. It's a tremendous amount of work. It's very labor intensive. So you've got to pick and narrow it down to what you think is going to give you the best chance of achieving your ends, which would be, coming out with some positive results. And there's a process of hypothesis testing that goes into actually deriving the what's your hypothesis going to be. You've got to narrow it down, because you can't test everything. You can drive yourself crazy trying and never get to an end point.
No, but Mitch's example of who has won at a particular time and whether that's significant, that is just comparing winners against winners. That's quite straightforward. That I can do now.
I think if you look at the transits of the winners, though, it might be able to help you zero in on the planetary issues within the birth chart that you might want to look at. Like, in other words, if they were having like Jupiter on their sun, well, maybe you want to look at the sun signs. Or if they were having, a Jupiter return, you might want to look at the Jupiter planets in the chart. It might help you zero in on what the significance is in their chart that is causing him to be a winner in the first place.
Yes, I agree. Again, it comes back to Courtney's point about there's only so many hours in the day you can actually research things. It was just trying to, does it seem to stack up? The answer seems to be yes, it does. But now I'm at the point of trying to define things down into much more manageable levels where I can take it further. My query has been, what is it that I'm narrowing down to look at? To look at things like transits or other techniques as to why things occur. At the moment, I'm just being more concerned with, do they occur or do they not occur, rather than can you explain why? If you wanted to look at people's transits as to why they were successful in a particular career, then it assumes that they are successful in a particular career, and then you can look at the transits to explain why. I'm just asking, are people successful at a particular astrological time or not? And the answer seems to be yes. Now I've recorded all the people that win. I've got 3 years worth of data about that, but I've never actually looked at particularly why somebody would win 6 times out of 10 compared to the other 4 people that win at that time as well. And it's that data. Now, if I can do that, I said it's by 90 degrees because I divide the size by modality, then in theory I can do that. So I have a data set there that I didn't realize I had a data set for up until this conversation.
Okay.
I'll hold back explaining why I think it's significant until I can demonstrate something more than that. But
Well, for a conversation that started out with p-values, I think we've actually covered a lot of ground as to, you know, where they apply, and you know, where it's more appropriate or not to use them. So it sounds to me like with what John is doing, using complete population sets, that any kind of significance is going to be significant. Anything that stands out is going to be significant. And here's another question here, you know, like what is your goal in doing this? And I know we've talked a little bit about this, because look, maybe, you know, maybe you want to get better at making money at it. Maybe you want to shove something in the skeptic's face to show them, look, astrology really works, that they can't really argue with. Maybe you just want to make something that astrologers will, you know, grasp onto and get enthusiastic about. It kind of depends on your end game. Maybe you want to do some combination of all of that.
Well, astrology is a bit like peeling an onion sometimes. You've just got to go and unpeel the layers and just see where it takes you. So yes to all of those, but I don't mind where it takes me.
Well,
but the other thing that strikes me as well is a little bit about, you know, what I'm doing is real-time events. Maureen's talking about real-time events such as transits. I seem to remember Faith being interested in birth data and Chiron and Pluto, and whether there's a native potential for something like that. It's dividing those areas of interest up into separate reasons. I'm just looking at, does the event occur, yes or no? There's the real-time event of transits, and then is the natal potential there, which is something that Faith's looked at previously.
No, if I can interrupt for a second, I actually, please finish. I'll add to what you're saying. When you're
no, we're going to get to you, Faith. We're going to get to you. Hold that thought.
Yeah, no,
okay?
I'm sorry to
thought.
interrupt.
Yeah.
No, please go, Faith. I've made my point.
Yeah, the little correction I was going to make is that, and in fact wanted to confirm, is that even though I started with natal charts, once I arrived at the bullet points, the 4 or 5 different manifestations of the aspect, which is always the case with aspects, that there are 4 or 5 manifestations, then when I looked at transits, sometimes people don't have it in their natal chart, but when they have the transit, they'll have one of those manifestations. Like, for example, right now I'm doing a sample of viral videos, because one of the attributes of Pluto Chiron is kind of a mass cultural event. And in a couple of the instances, people don't have the Pluto Chiron symbolism in their natal chart, but at the time their video went viral, they had the symbolism. They had the transit, for example. So not to take you too far off the track, but okay, just to make that point.
Well, I think it's good to bring in Faith's project or projects to the discussion, because, you know, we've discussed extensively using qualitative methods to organize her questions she's asking of the data, but at the same time, there's a lot of quantitative potential in what she's doing. And, you know, Mo, Faith, I don't know if you're familiar with what Faith is working on, but actually there's a lot of transits involved in it.
Yes, and progressions.
Do you want to maybe give
a viral video?
John a little elevator pitch on what exactly you're doing, just so they
Sure.
Yeah.
Well, my whole all of my research work has to do with aspects, and for the past, I don't know, let's say 10 years, it's been on aspects to Chiron, and for the past 2 years, it's been on Pluto to Chiron. And I started out looking at Pluto Chiron in terms of resources, because one of the attributes of Pluto is resources, financial resources, and I have had some success with that, with financial downfalls, with tax avoiders, with various kinds of either financial problems or miscreants. So there's that. But as I got further into it, I found that there was, and somebody brought up the point of keywords. I found a repetition of keywords, and one of them had to do with, I don't want to just call it a cultural, but phenomenon that caught on in a big way. I'm sorry?
A craze.
A craze, a mania. Those are, you know, words that came up more than once.
Video.
So lately, I have been, because of, you know, my involvement with this research project in reformatting my material, which is, you know, I mean, it's qualitative and it works fine on that level, but in trying to conform to a research model, because a lot of my work has quantitative samples of 10 and 20, you know, that's all over the place. And I've asked this question, what constitutes a good sample? At any rate, I've been looking for something to kind of hang my hat on. And yesterday or last week, I heard a song that lived in my head. And when I looked for it, I found it went viral. I thought, now that's an interesting Pluto-Chiron concept, because in fact, the guy who made that particular song that went viral had natal Sun equaled Pluto equaled Chiron, all in an aspect, and that's one of the things about. We're still good. Oh, hello. Hi, we're still good?
Yeah.
Yeah, so that's one of the things about Pluto-Chiron, is when you hear it, you know it. When something kind of catches fire like that, the likelihood that there's going to be a Pluto-Chiron component is pretty strong. Your probability value is pretty good.
Let's take that example right there, okay? Let's say you're designing a quantitative experiment.
Yes.
Looking at Pluto-Chiron transits when somebody experiences being the focus of a craze.
But Courtney, forgive me for interrupting you, but this is actually, you know, germane to the point that you guys were making, is that the same phenomenon can manifest either in the natal chart or at the time of a transit. Because the first viral video guy I looked at had it in the natal chart and by progression. The second viral video guy did not have it in the natal chart and had it by transit precisely.
Okay. But when we're trying to make a quantitative question out of this, we've got to narrow down the parameters, because like, well,
this is the, you know, actually what got my attention about Maureen's comment is, does a transit have the same kind, is a transit equal in evidence as a natal picture?
Well, I think that needs to be part of the research question that you're asking.
That's right. Depends on the question that you're asking.
And you would need to clearly define your parameters and your definitions of what you're looking for. And once you've clearly defined that, and again, just for example, let's say you've got 25 charts of somebody that was the subject of a craze, and you've already said that maybe it's natal, maybe it's transit, maybe it's progressions. Well, see,
Correct.
That's a research question right there. Is it natal? Is it transit? Is it progressions?
Does it matter? Does it matter? Does it matter?
Well, yeah, but the way we would determine if it matters is it's a quantifiable question of your data set of 25, and obviously you want more than that if you can get it. But whatever you've got, then you need to do the count. You know, analyze it and get a graph, and you analyze it by really narrowing those parameters down so that you know exactly what you're looking for, and you're looking for exactly the same thing in each chart, and then you can notate, this guy's, you know, got it by natal and by transit. This guy's got it by transit and by progression. This guy's got it by transit, natal, and progression. You know, you're on a chart, you're in a spreadsheet, the numbers are adding up. When you get to the end of that data, then you've got some numbers, you've got some degrees of freedom. Mitch, maybe you could clarify, is she looking at, you know, chi-square analysis there, or what's the best route?
If she has a table, she's probably looking at a chi-square analysis, I would think.
Because she's got X number of degrees of freedom. She's got X number of things that she's testing.
Yeah, well, degrees of freedom is simply assuming is making sure that you have enough observations that again, I'm struggling because I don't want to do a numeric sort of thing, and I'm trying to come up with a good language for what degrees of freedom is showing. Degrees of freedom shows you the degrees of freedom. The calculation is simply the size of the sample minus the number of parameters that you're trying to estimate. So if you're trying to estimate 3 variables and you've got an N of 25, then you will have 21 degrees of freedom because you're also going to be probably looking at an intercept. If not, if it's a chi-square for a statistic for a table, and you had 3 out of 25, then you'd have 22 degrees of freedom.
But yeah, and again, this brings up the point, you can't test everything. You know,
No,
so
you can't
you
test
have
everything.
to narrow it down to the things that you think show the most promise.
You got to have at least one residual degree of freedom, preferably more, in order to be able to have to do the test at all. If you don't have any degrees of freedom, you can't do the test.
Would you define a degree of freedom one more time?
Yeah, degree of freedom is an observation that's free to vary. We take and count the number of variables in our analysis. We subtract that from the number of observations.
One of the best examples is like signs of the zodiac. Say you're just testing for planets and signs. You know, do doctors have Mars and Scorpio more often?
Right.
Well, there's 12 signs of the zodiac, and let's say you have 300 doctors, so that gives you what, 11 degrees?
280 degrees. It gives you 288 degrees of freedom.
Okay.
300 minus 12 would be 288.
So forgive me, if I'm looking for evidence for the aspect relative to the event, how many degrees of freedom am I using? Not that I understand what I'm saying, but just to try to understand.
It sounds like
if I'm looking at the potential for the aspect to show up in the natal, the progression, the transit. I can't do solar arcs. I don't have enough info. But if I'm looking at 3 of those possibilities, how many degrees of freedom am I looking at? One aspect, 3 possibilities for appearing.
How many observations do you have?
Well, so far I've got a half a dozen, but I'm 6 for 6 here so far.
So you got a half a dozen observations.
Yeah. Oh, there's more to come. This just occurred to me as an interesting sample for a mania.
If you were to put that in a tabular form, you would wind up with 3 degrees of freedom.
Okay.
And that's going to be too few degrees of freedom for most statisticians' comfort.
Say that again. That's
going to be too few degrees of freedom for most statisticians' comfort. We generally want to have more degrees of freedom than 3.
Just a question.
So she would need more people in her sample.
Right. We want a bigger sample. Right.
I wouldn't recommend that you test more things, because just testing transits, progressions, and natal, I mean, that's a lot right there.
I agree.
So the more people in the sample will really flesh it out. Obviously.
So Mitch, are you saying, because actually you've just kind of put the kibosh on the 3 degrees of freedom, that from a statistical standpoint it doesn't work?
With only 6 people in your sample.
No, only this week there's 6 people. By January 20th, hopefully I'll have 60.
And that's going to raise the degrees.
That's going to raise your degrees of freedom.
Got it. Okay, it's relative to the size of the sample. Got it.
Absolutely.
Okay.
The more the merrier.
Absolutely.
Got it. Okay. Maybe not 60, but anyway.
It's the size of the sample minus however many measures you have.
I understand. It was the 6 that was the deal breaker. Got it.
Yes.
You know, and I would also, how can I put this? You don't want to be comparing apples to oranges. And I think that's a common mistake people make in astrological research. They want to get a big sample. So they lump in a bunch of apples, oranges, and rutabagas together, and it all comes out as a wash. So if you're looking for manias, I would look at a specific type of mania.
Like viral videos.
And I would say, well, viral videos is one, or even, and I mean, you're free to choose whatever you want, but just for example, you know, there are certain popular songs that are so big that they start a craze. And then there are others that kind of just go to #1 and leave. But then, you know, you could go through the Billboard history and choose popular songs that were more than just a hit. They started a dance craze that everybody was doing. You know, that narrows it down, but you're still going to have like 50 or 60. And then you can probably get, maybe not time birth data, but at least a birth date for the major singers or band that were involved in that. And at least you'd be dealing with a very uniform kind of event. You're not comparing apples to oranges.
Yeah. Well, if you do music, Frank Clifford's just come out with a book that's a compendium of charts for musicians.
Yeah, so there's data out there. But now, when you say viral videos, again, you wanna be specific, and also
yeah, how do you define?
Yeah, a viral video.
Well, I'm using the list from Wiki.
Okay, that's good. And then again, the question is like, whose chart are you looking at? Is it the cute little kid in the video that went viral, or is it the parents that took the video?
Well, I'm not sure. Most of the people wrote it. So far, most of the people have written the song. That may not be the case in every single instance. But I am working with,
or the person.
Yes, the person who wrote the song. But I am looking at a fixed list of songs that went viral, videos that went viral, that conforms to my premise about Pluto Chiron. And I'm actually looking at an objective list. In other words, somebody agrees that these songs represent viral videos.
And that's good.
There
the
is
list
usually
is curated by somebody who's not an astrologer.
Exactly. So anyway, I'm going to leave it there, not to take a, I'm going to leave it there. I feel like I have a ton of material that has nothing to do with viral videos. It's just that when the song, I got the earbug and I read the word viral video, I thought, wow, that is a Pluto Chiron phenomenon.
Viral
I'm pursuing it. Exactly. I'm looking at the list. I hadn't counted it, but there's got to be at least, let's say there's 20 on the list. And, I got my work cut out for me there. And there's usually a name associated with the song.
And don't underestimate the value of exploratory research. It can be an exploratory research project with 20 in the sample, and you can say these are the preliminary results, and now we want to test it on another larger sample in the future. Now
keep in mind that this is refining the first draft of this, which includes people like Elvis.
Right.
So it's not as if this is, the first foray into this. This is there's a guy, I forget his name, but he talked about the creative mathematics and the stages of creative mathematics, where it was observation, incubation, and then confirmation. I feel like I'm at the confirmation stage of this work. I feel like I've got my bullet points, and from here on in, I'm just confirming it with data. I'm confirming it to make it conform to the presentation that I'm making.
Right.
For me, it's pretty near. I feel like I've arrived. Yeah.
Yeah. But I mean, you're right. When you brought up viral video, I happened to catch a rerun of the Ed Sullivan show the other night where they showed the Beatles doing
which, by the way, happened. It happened precisely on a Pluto Chiron opposition.
To who?
it was in the sky, the transit.
Okay, because really what was fascinating about it, as much as I love Paul McCartney and the Beatles, was the scenes from the audience.
Yeah.
Because literally the audience was full of teenage girls, and they were completely besides themselves. You know,
That's
they were
right.
screaming their heads off. And, you know, Beatlemania, and it kind of, you know, took me back. I was just a tiny wee girl then, but there's viral videos, and then there's Beatlemania. And
Correct.
I think those are kind of two different things.
Not
So
really.
I would be cautious. I would be cautious about lumping them in. You might be comparing apples to oranges.
I don't agree with you, Courtney, because they're from taking it out of the entertainment realm. There's Timothy Leary and Sigmund Freud. In other words, it's not necessarily.
This is a research question. I mean, this is the kind of thing that I think would be best determined quantitatively. Are they the same thing? Are they?
Well, in my point is that it's a mass consciousness that among the ways it manifests is entertainment crazes and manias.
And here
It's
we
not.
go. If the Beatlemania and the Ed Sullivan Show occurred under a transiting Pluto-Chiron opposition, then everybody was getting it.
That's right.
And
That's
that whole audience of screaming girls extended all the way across America. And they were literally out of their minds, screaming their heads off. And you have to, I know we lived through it, but you have to go back and see it in 2018 to just go, wow, that was weird. That was a transiting opposition.
Correct.
Which had a more maybe widespread effect. And that might be one of the differences that you're going to find in transiting versus natal versus progressions. Maybe it's worth looking at.
Good.
Just
Thank
a
you.
suggestion. We seem to have touched on this chi-square conversation, and you suggested earlier on there may be a video that you could show us. Is that something for next time?
I have it queued up if you want to see it. It's
Yes,
really good.
please.
It's really good, and it's Bruce Schofield, and it's about like 26 minutes long. And he does a good, concise introduction of the chi-square for astrologers, and he uses it in a simple astrology research question.
Well, I was just looking at the Mercury hour, and we're well over the hour now. I was just thinking, is that another subject for another time? Or
I will leave it to you guys. Do you want to see it now, or I'll put it on the website when I post this video?
yeah, that'll be great.
Would that be better rather than?
That'd be better for me, yes. But it's been interesting. We've talked about p-values, and we've got everybody involved, and the conversation has developed. I'm just concerned that if we start talking about chi-square, and I've no idea what that is yet, that's going to take on another hour and a half to get into it.
You're right.
Seems to be another subject for another time.
I've seen the video several times. I could probably stand to see it a few more.
But I mean, Maureen, you have to admit, like, for breaking it down for normal people, he does a pretty good job.
He does.
And makes it relevant.
Right.
Yeah, because it is very relevant to a lot of astrological questions. But we'll post that on the page with this video, and maybe look at it in class.
Then I'll do my homework first, and then I'll wait for next month.
Okay. Well, good. Yeah, it's been a Mercury hour and 15 minutes, but I think that this has been an intense conversation, but it's been incredibly productive, and I want to see more and more astrologers having these kind of conversations about how to take their work and really manage it into something that's going to be meaningful to everybody.
Right.